Let's start going through the bell work. On number 1, if k is 3, what is x? Yes, sir? 10. Absolutely correct. Let's talk about how we get there. So if I have x minus 1 over 3, and we substitute in 3 in the place of k. I want to get x by itself, so I'm going to need to get rid of that fraction. How do you get rid of a denominator? What'd you say? Multiply, yes. So we're going to multiply both sides by 3. That's going to cancel our denominator out. That would give me x minus 1 equals what? 9. And then we add 1 to both sides. And that's how we got x equals 10. So far, so good? You're shaking your head, Chris.
I didn't do it that way.
You didn't do it that way? How did you do it?
I just, you know how if you divide 9 by 3 equals 3,
Mm-hmm.
and then you minus 1, it would be 8. So if you did 10 on the top instead, you would get 9 after you subtracted 1 from it.
Nice. Yeah, there wasn't necessarily any one particular way that you had to go about doing this one. Absolutely. Number 2. I mentioned that you would probably want to try some guess and check here because it says as x gets infinitely larger. What does that mean? What does it mean for something to get infinitely larger? Close. Very close. It's not necessarily that it has a lot of solutions, but infinite indicates what? Yep. So when does it stop? Never. So it never stops getting larger. It never stops getting bigger. X is going to get past 10, past 100, past 1,000, past 1,000,000. So I'm going to try some very large values of x. I'm going to pick easy numbers to work with, like 1,000, right? We're going to substitute it in. We're going to see what happens. We're looking for a pattern here. And we're looking for what value this approaches. It doesn't have to get exactly there. We just want to look for what is it getting close to. So I'm going to let x equal 1,000. Grab your calculators for me real quick. Huh? Give me a moment. If x is 1,000, what would the numerator be? If x is 1,000, what would the numerator be? Right here, guys. If I put 1,000 in the place of the x. 3,000 what?
X.
Not 3,000x. We're taking 1,000 and making it take the place of the x. 3,012. Because I would take the 3, I would multiply it by the 1,000, and then I would add 12 to it. So 3,012 would be my numerator. What would the denominator be? 1,988. Divide that real quick on your calculators. Tell me what it is about. I know it's not going to be very pretty, but what is that about? You said 1.5 what?
1.51.
1.51, okay. Let's try another large value of x. Let's go bigger than 1,000. Let's go 100,000. 100,000 has 5 zeros in it, okay? If I took 100,000 and I put it in the place of x, what would the numerator be? 300,012, because remember, we're multiplying it by 3. What would the denominator be? we put 100,000 in the place of the x. So 2 times 100,000 minus 12.
199,988.
Divide that on the calculator and see what it is about.
How many nines is that?
3 nines. 199988. You said 1.50 something?
Yeah.
What'd you get, Sierra?
0, 1.
Like that?
Oh,
No, that's another 0.
There's another 0 and then a 1?
Yeah.
Okay. Let's try one more big value of x. Let's try 1,000,000 this time. Do you know how many zeros 1,000,000 has? 6 zeros. All right, so let x equal 1,000,000. What would this fraction look like if x was 1,000,000? 3,012,000 over what? Let's divide those and see what it comes out about to. You said what? 1.5000. That's really, really close to 1.5, right? If you had $3 million, would that extra 12 make a huge difference to you? I mean, I want the extra $12, don't get me wrong, but it's not going to make or break me if I've got $3 million. So 3 million and 12 is, What about if you had almost 2 million? You were just $12 short of 2 million. You'd be fine with that? So as x gets bigger and bigger and bigger, does that plus 12 on the top really matter that much? Does the minus 12 on the bottom really matter that much? Not as x gets bigger and bigger and bigger and bigger and bigger. Which one of these numbers up here, A, B, C, D, or E, is the closest to what our fractions kept getting closer to?
3 over 2.
3 over 2, choice E. 3 over 2 is the same as 1.5. And as we made x bigger and bigger, we got closer and closer and closer to precisely 1.5. We started off pretty close, even when we did the let x be 1,000, didn't we? This idea right here is a concept called limits. It's introduced in later math courses, but this is an SAT prep question. This is the kind of thing that you could expect to see show up on the SAT or the PSAT. And I want to show you guys that it's possible to do this type of question even though you've never learned about limits. They said as x gets infinitely larger, and so we can just guess and check with some really big values of x and see what happens. For the rest of the class period, I will take whatever questions you guys have over the review. I will work through any problem numbers you wanted to see. You need a copy of the review. Yes, sir. You need another copy of the review? Okay. And does anybody need another copy of the cheat sheet, Coriel? I know you need one. Isn't that your purple sheet right there?
Oh, it is. No.
Okay. There's your review. There you go, Coriel. Yes, ma'am.
I didn't see the review at key on Canvas.
You weren't able to find it? Okay, I'll show you guys where that is. You found yours? Okay. The key on Canvas, if you guys want to go and check that out, from our class homepage, if you click the big red button, it'll take you to the today's lesson page. That's what I've got up on the screen right now. If you scroll all the way down to the bottom, underneath where it says homework, it has the answers right here. And underneath the answers, there's a link for all my work. All right? It's in a PDF form, so you can open it up on your phone, on an iPad, on a computer. It's still going to look the same. So that's where all of the answers are. One of the things that I would definitely recommend having on your cheat sheet would be an example of a graphing problem. We spent about 2/3 of all of our time in this unit on graphing. Yes, sir. Nurse? Yep, give me just one second. If you guys want to put some graphs on there, I have some graph stickers that you are welcome to use. I'm going to set those up here on the table. If you want one, come grab one while I write this pass. So like I was saying, I would make sure to have an example of a graphing problem on my cheat sheet to use on the test tomorrow. Yes, sir.
What are the
Oh, those different values for n. Let's go look at that particular problem. There we go. This is a good one for us to look at. Number 6, if you see continuously, what do you want to make sure to use formula-wise? Yes, the one that has E in it. This would be A equals P e to the power of RT. If you see ones that have words like monthly, daily, weekly, quarterly, that would be a different formula. What would we use then instead of the formula with E? The one that has which letter? I thought I heard somebody say it. Needs to have an R in it. A equals P. It is R over, not T, but over N to the power of NT. And in this case, the N goes with each of these words. Monthly, how many months in a year? 12. So we would use 12 if it says monthly. Daily, how many days in a year? 365. Anybody know how many weeks in a year? 52. Quarterly. How many quarters are there? Yes. 4 quarters in a year, just like 4 quarters in a dollar. That word quarterly means to take something and cut it into 4 parts. So if you talk about quarters for anything, it's always 4 to make a whole. Do you guys want to work through this one since we're here? Okay. One of the things I want to point out, function rule. This is not the same thing as a formula. A formula pretty much has only letters in it. A function rule that describes this situation, I have to take any numbers that they've given me up to this point and I need to substitute them into the formula. That would give me a function rule. So we already said which formula we would be using. That was this one right here. So I have A equals, what could I substitute in for P? 2,000. We don't substitute anything in the place of E. Why? E is already a number. What would I put in for R? Yep. We're going to take this, divide it by 100. And that is 0.063. And then I would leave the t there because up in this part of the problem, I don't have any other information. I don't have something to substitute in for t. A function rule has two variables left in it. It has an input variable and an output variable. Whenever you write a function rule, there should only be two letters left. Everything else should be filled in. You guys want to work through part B? Okay. How long will it take the initial investment to double? How much would be in the account if it doubled?
Twice the number.
Twice as much. Twice what number? 2,000. They initially invested 2,000. So twice that would be 4,000. I'm going to put this in the place of what?
P.
Not
Oh,
P.
A.
A. P is always my starting amount. So whatever initially got deposited, that amount's not changing. Some future amount is what A means. So I would have 4,000 equals 2,000 E to the 0.063 T. I want to get E all by itself because I'm needing to isolate T. We would divide. Divide both sides by 2,000. What is 4,000 divided by 2,000? 2. Equals E to the 0.063 T. What I'm looking for is where?
T.
T. Where is that in the problem?
By the decimal.
It's by the decimal.
You'll have to move up.
Yeah, right now it's part of the exponent, and I can't solve for things that are exponents while they're still there. So I'm going to need my triangle. What is our base?
2. Well, E.
E is our base. What is the exponent?
0.063.
Yep, 0.063 with the t with it. So what's the argument? 2. These two pieces are both numbers, right? So that's what I need. What operation lets me use just those two? Starts with an L. Log. So we're going to do a log with a base of E, argument of 2, equals my exponent, 0.063 t. Log base E we normally just call what? That's my natural log. ln. That's the button that I'm going to go looking for on the calculator. How do I get the t all alone? Divide. We're going to divide both sides by 0.063. And when you divide that, it comes out to be like 11.00 something. So this is about 11 years. Part C, you would do almost the exact same way. We still are interested in it doubling. So I'm still going to have that 4,000 equals 2,000 E. This time they're asking me what the interest rate is, but they gave me time. So I don't know what R is for this part. But I do know that time is 8. I would solve this problem pretty much the same way that I did the other one. I would get 2 equals E to the 8 times t, and then I would use my triangle to be able to rewrite this. Base is e, exponent is 8t, argument is 2. The variable is up on top, so I want to use just these two. When I'm using the base, we're doing a log, or when I'm using the bottom of the triangle. So log base e of 2.
Wouldn't it be R8 instead of 8t? Because we already have the time for 8.
Oh, yes, sorry, 8r, you're right. I had the r written up above, and I'm so used to writing the t. You are absolutely correct, sir. Thank you for catching that. Log base e, that's my natural log. So this would be ln of 2 equals 8r. And then I would divide both sides by 8. Grab your calculators for me and tell me what you get when you sub that in. When you do ln of 2, close those parentheses before you divide by 8. I know it starts with a 0. 0.08, and then it's like 6 something, right? So here's what r is. At the beginning of the problem, we always take their percent and we do what to it? Divide it by 100. So if I have something that looks like this and I want to know the percent, I can take this and times it by 100 so that I can get the percent back. 8.66%. I would accept either one of those on a problem like this. For part D, we're back to our original function rule, and I want to know how much money would be in the account in 25 years. Where would I put that 25? In for T. So into my calculator, I would put 2,000 times e to the power of 0.063 times 25. If you're using one of my yellow calculators, you can make sure that the 25 is still part of the exponent. If you're using a blue calculator, you would need to make sure to put parentheses around this, because otherwise the calculator thinks you want to do e to that decimal power, and then you want to times the whole thing by 25. So you'd get a wrong answer. Does anybody know about what this comes out to? Yes, sir.
Is it 9,661?
9,661, and what would the pennies be? 0.48. There we go. Thank you, sir. All right. Did you guys want to work through a graphing problem together? Okay. Yes. One with a hole? Absolutely. So let's do a graphing problem with a hole.
I'm going to take a picture.
Okay. There are several to choose from. I think one of the best ones on here, because it hits all the pieces, is number 2. Number 2 has like all the different things that you might need to do with a problem that has a hole. So I'm going to go look at that one. What's the first thing you notice about the numerator and the denominator here? Needs to be factored. So we're going to factor this guy. Is there a GCF here?
No.
No GCF. And we need to factor the denominator. Does this one have a GCF? Nope. No GCFs on either one of those. Let's do the denominator first because I can use my shortcut on that. I need two numbers that multiply to give me -2, but add to what? Adds to 1, my b value. What multiplies to -2, but adds to +1? -1 and 2. So I'm going to rewrite that denominator in its factored form. X minus 1, x plus 2. Let's go factor the numerator next. I'm going to do that over here because I've got a little bit more room. Multiply a and c together, so I need two numbers that multiply to give me what? What is a times c here? -12. But adds to my b value. What's my b value? -1. What multiplies to -12? Oh, sorry, it's a +1. No, it's a -1. I was looking at the wrong spot. Good grief. What multiplies to -12 but adds to -1? -1 and 3 wouldn't multiply to 12. -4 and 3. Can we get away with our shortcut here? No. I have to do the area model. We're going to put our a value here and c here. So I've got 4x squared and -3. I'm going to take those two numbers that we just found, -4x and +3x, and put them in. What can I take out of 4x squared and 3x? X. What can I take out of -4x and -3? -1. So there's one of my factors, x minus 1. Let's go vertically now. What can I take out of 4x squared and -4x?
4.
Yep, I can take a 4x out. What about 3x and -3? What'd you say?
-3.
I can take a 3 out. Would it be positive or would it be negative? Positive. It's touching a box that's positive, and so I take that positive out with it. So 4x plus 3 is my other factor here. Now that we have it factored, what do you notice? X minus 1 cancels, which means what's going to happen on my graph?
It's going to be a hole.
There's going to be a hole. There is a hole where x minus 1 equals 0. I'm going to write down what we've got left over after we canceled. 4x plus 3 and x plus 2 is what we had left. What is the x part of the ordered pair for the whole? I need an ordered pair for where this hole is. X minus 1 equals 0.
So you add on both sides.
Add 1 to both sides. This will tell me the x part of the ordered pair. X equals 1. So I'm going to start my ordered pair here. 1, comma. How do I find the y part?
You sub it in for the other.
Yes. We're going to substitute it in here and here to find the y part. To find the... What'd you say, dear?
Where do we sub it?
We're going to sub this 1, the x part of the ordered pair, in to what we have left over. So that 4x plus 3 over x plus 2, everywhere we see an x, we're going to sub a 1 in. Y equals 4, and then I'm going to put a 1 in. Plus 3 over, and I see another x down here, so I'm going to put a 1 in. Plus 2. So what's my numerator?
3.
7, because I have 4 times 1, which is 4,
5.
plus 3. That's okay. What's the denominator?
Not
3. Yep.
Yeah, that's what I think.
There's the y part. So 7/3. Or since we're going to have to go and graph that, when I put that in my calculator, 7 divided by 3, I get 2.3 repeating. Because I need to know about where that is on my graph so that I can circle it. Transformation form. This is AHK form. When you look at what we have left over after we canceled, 4x plus 3 over x plus 2, can you tell me what AH and K are from that? No, then what do I have to do to get it into AHK form? Yes. We're going to use long division to put it in that form. So I'm going to have x plus 2 on the outside and 4x plus 3 underneath. What are we going to have up on top? How many whole times? What'd you say? 4. I'm going to take that 4 and I'm going to distribute it to both pieces here. 4 times x gives me 4x. 4 times 2 is 8. After we do our distributing, what do I have to do?
Flip this.
Flip both signs. So this is going to become subtraction. This one will also become subtraction. 4x minus 4x, that cancels. What's 3 minus 8? Negative 5. So here's my remainder. Here's my whole number. Help me write this in transformation form now.
4 over.
Do whole numbers belong in fractions?
Oh, no.
Negative
Negative
5.
5 over x plus 2 plus
Yes.
4.
There you go. Negative 5 over x plus 2 plus 4. Remember, whole numbers don't belong in fractions. That's how we know that that's k off to the side. Remainders are still parts of fractions. That's why the negative 5 is up on top. Where is our vertical asymptote going to be? Close. X equals negative 2. My horizontal is y equals 4. That would be another good thing to make sure that you have on your cheat sheet. It's just horizontal horizontal is y equals k. Vertical is x equals h. Horizontal is your y equals, vertical is your x equals. So I'm going to go put those on the graph. Horizontal, right here. Y equals 4. Vertical, x equals negative 2. Right here. Which quadrants will we be in? The negatives. So I'm going to scratch out the positives because we're not going to be there at all. I'm going to go put my whole on the graph. It's at 1, and then 2.3 is going to be in between the 2 and the 3. I just need to circle it. Like if they show you a traffic map and they show you where the accident is, they're like, don't go here. That's what we're doing with our whole. We already said we're going to be in the negative quadrants. I'm going to need to count from where the asymptotes cross. What am I using to count? The a value. Our a value is negative 5, so I'm going to count 5 up and down, left and right. So from where they cross right here, I'm going to go up 1, 2, 3, 4, 5. I can't stay on the asymptote. I can't go into the part that we scratched out. So I'm going to hop over here. We always hop 1. So right here's my first point. Go back to where they cross. I went up already, so now I'm going to go down. 1, 2, 3, 4, 5. And I'm going to hop in 1. Right here. We went up, we went down, we still need to do what? Left and right. So from here, left, 1, 2, 3, 4, 5. Can't stay on the asymptote, so I have to hop in 1. Right here. And then I need to go to the right, back to where they cross. 1, 2, 3, 4, 5. Hop in 1. It's going to lay close to the asymptotes, but it also has to go through those points that we plotted. Would this be correct? Why not? Can't go through that hole. That's a gap in my graph, so I can go up to the hole, then I have to jump over it or come up to it from the other side. Cannot go through the middle of that hole. How would you use words to describe this transformation? It has been reflected over the x-axis. To the left 2. Up 4. There's one more thing. What was that a value again? A was -5. The negative did the reflecting, but then you're absolutely right. It stretched it also. This has been vertically stretched by 5. All right. Guys, I have these graph stickers. If you want to grab some on your way out the door to put them on your cheat sheet, you may. I would absolutely have an example of a graphing problem. This one had all the things. It had a hole. We found the x part and the y part. We had to do long division to put it into transformation form. We graphed it and we described it. Other things that I would make sure to have on my cheat sheet. Have an example of solving an equation with an equal sign where you have your LCD. Have an example of one without an equal sign. You can't use the LCD then, you need to get a common denominator. But there's examples like that in number 11. Remember the answer key up on Canvas. Click on the big red button that says today's lesson, and if you scroll all the way to the bottom, the answers are here in green, so if you just want to check your answers, you can look there, or the key is all the way down at the bottom, and you can click on that to get the PDF. Have a great rest of your day, guys. Let me know if you need anything at all.